Hello, my name is Holland Dotts, and I'm a senior consultant at Mountain Point, where we offer technology advisory, implementation, and support services for manufacturing organizations. In this episode, we'll hear insights from concrete industry expert Matt Terranova, and we'll also be showcasing a demo of kBridge's Structure Designer application. Over the past few years, we've seen a growing demand for visualization solutions in the manufacturing space, and we've partnered with kBridge because of their platform's unique ability to meet complex engineer-to-order demands with both 2D and 3D visualization. Also joining us today is Chris DiEllo, my co-host in this webinar series. Chris, I'll hand it over to you to introduce yourself and our guest today.
Awesome. Thank you, Holland. So Chris DiEllo here with Engineering Intent, also known as kBridge, our software platform for ATO manufacturers. And today, not only am I happy to be here with Holland, but also we're thankful to have Matt Terranova with us. Matt, I had to look it up yesterday. It's been 18 years since we met when you were with PL Custom, if that's
Yeah.
a way to call a
Yep.
company, a custom manufacturing, ambulance manufacturing company, right? Or rescue vehicle,
Yep.
first responder vehicle. So Matt's, I'll let him describe his career evolution here, but right now currently involved in concrete consulting, and that's really his role and the credibility and explanations and so forth he'll add today. So Matt, if you wouldn't mind introducing yourself, please.
Yeah, sure. First off, thanks, Chris and Holland, for having me here. Can't believe it's been 18 years, Chris, but it's been a good 18 years.
There you go.
Yes, so my background currently, I work for RHA Concrete Consultants. We've been consulting on concrete projects for roughly 50 years. My background, I started in concrete right out of or in college with one of my first jobs, and it kind of runs in the family essentially. And from there, I worked on different portions of concrete construction, from design up to the actual construction of that, and in there weaved in some time at manufacturing companies and also some design companies as well, and also some formwork companies. So I've kind of been in and around concrete construction for the past 20 to 25 years on both the design side, the manufacturer side, and on the construction side.
Great.
Awesome.
Thanks, Matt.
Yeah. Yep.
I know when we first met up to begin planning this production, if you will, one of the first things I found very interesting was just getting a lay of the land as far as some concrete industry specific terminology. So if you wouldn't mind covering at a high level some of those terms.
Yeah, sure. Concrete can really be hard to describe at times, even though it is the most used construction material in the world, but it's also the most misunderstood. So for a lot of people, you can divide it up into cast in place, concrete, precast, and then tilt up, which is a combination of the first two. And essentially, the cast in place and precast are what most people would be commonly, used to. And cast in place is the unique portion of concrete where you're taking something that's in a liquid format, bringing it to a job site, placing it in some formwork, and then letting it harden. And once you strip it, that is going to be your final shape. And most people see this in their foundations, or they'll see it in the walls of buildings and things like that. This can also be the floors of your high rises and mid rise buildings. And then there's precast, which is similar in the sense that you are taking a liquid form and putting it into your formwork, but you're doing that in a controlled environment offsite. And most of the time, these are very large facilities or warehouses where they'll produce a lot of different types of shapes that are used for not only buildings, but they'll be used for utilities. But it's highly repeatable designs that are then shipped to the site and put in place. And tilt up can be either or. So you can have large panels, which are then tilted up and put into place. So think of your Costco warehouses or your Amazon warehouses, any of those big box retailers, where you'll have that concrete either be delivered to the site and formed, or formed at a precast company and then brought in and put into place. So those are really the main types of concrete that most people see every day. Not necessarily a difference in the finished product, but how you get there.
Great. Thanks so much. Uh, I'm wondering, in your experience, what do you see as some of the biggest challenges in the concrete industry?
I think coordination, is a challenge. Working in conjunction with not only the design teams but also your other trades on the project, whether it's your HVAC or steel or electrical. Um, the turnaround of documents in a timely fashion, I think, is always a challenge for everybody on a project. Probably not just concrete. Um, and providing a good schedule, an estimate of that schedule. Schedules are very fluid when it comes to construction, and being able to coordinate all those and be able to tie them back to the project itself, whether it's from a modeling standpoint or from just a strictly time frame standpoint. Those are all important things that we'll, in general, see a lot of challenges with.
Makes sense, Matt. And so, how have you personally, in your experience, and how do you as consultants even work with design companies to help them overcome those challenges?
Good question. It's a lot of pre-planning, right? So trying to get the specifications clearly defined, try and get in front of the design teams early and be part of that process of going through that pre-planning and getting to that point where when you do start to think about the actual construction, everybody is involved, from the people who are bidding the projects to ultimately get the projects. They understand what is expected of them. Especially when it comes to concrete, it's very difficult to go back and change. Right? It's easy to frame a wall and then say, oh, this isn't correct, or to replace a part of it. It's difficult in concrete to do that. You usually get one chance, and then to demo and take that out and to have to redo it again, all very costly and not easy fixes. So from our point of view, it's to have those documents, whether it's specifications, drawings, being able to get ahead of the game with those and be able to provide your feedback and support early on rather than after the fact, or find yourself then playing catch up.
Yeah, that smart. I get all that, and I suspect the audience will as well, as they live it, regardless if they're in concrete or otherwise. Is it, I guess my selfish belief from experience is that technology plays a big role
Mhm.
in helping uh, or allowing those design elements to be done faster and ultimately shared, collaborated with the larger group. And any work that can be done in the design phase in a shorter time frame gives the production and installation or construction phase that much more time. But having not been in those areas, what do you see? How do you see technology really starting to play within the concrete and construction world?
Yeah, I think it's, especially the last 5 years or so, we've seen, technology be a little bit more um, useful, and as far as it's being user friendly and adaptable. Um, but yeah, as far as trends I've seen, the 3D modeling in concrete has lagged behind, but it's starting to pick up. Being able to have a single source of truth on a job is important. And I think the trend going forward is you're going to see, a lot of people like the idea of modeling, but there is a lot to it. And AI can possibly help take some of those repeatable areas of drawing production and be able to systematically take some of that off the designer's plate, where they're then focusing on the actual modeling and the more important aspects of the data driven part of it, which is you can have a model, but if you don't have data attached to it in this day and age, you're really limiting yourself to how productive and useful you can be. So allowing certain things, whether it's labeling, dimensions, layout of drawings, those types of things, where if AI can which seems to be going that route, help with that and automate it and provide some rules where 80% of that can be done, and then you're just checking the 20% of it. Those are areas where, particularly with that type of drawing creation and modeling and those things, will definitely provide some additional uh, productivity that I think over time can continue to grow.
Yeah, good thought there. And we can seeing what tech is using or how tech is using AI, and knowing how we are beginning to use that within kBridge, more on the authoring side of rule creation and
Yep.
accelerating that. Um, we have internal arguments, so to speak, or discussions about. We've been doing AI for years, just because automation is quite literally that. We won't cover it today, but we have a MEP or mechanical, electrical, plumbing specific applications inside of kBridge that will route pipe or route ductwork, or place ceiling lights and so forth within buildings. And there's intelligence to that, certainly. There's anticipation of what those things are. And to your point, working with concrete isn't like working with wood. It's a lot harder to move something or drill a hole in something or whatever. So the more you can design that in, the more you can anticipate that, the
Right.
smoother you'll have the construction aspect be. So with that, I
Yep.
guess as tech gets more involved here, Matt, what
Mhm.
um, I guess what do you see in terms of the technology space out there? There's so many providers in terms of the architectural construction engineering world out there, and some of them work together, some of them prefer their own platforms. What's your experience around how all those pieces of tech interact?
Yeah, I think it in historically, right? You've had a couple companies that were able to provide their own solutions, and not have to have integration from different manufacturers, let's say. I think when it comes to this type of technology and what we're looking at in the future, I think interoperability is going to be key, because the adoption will be a little bit faster, right? If you're not trying to relearn, or you're not trying to have a piece of software do something that it's not really intended to do, but you want to stay within that single source provider. I think the key is going to be having some of these providers be able to uh, add some ability to collaborate through different platforms, and some of that can be done by just having add-ons or additions to your current software package that are going to be able to provide that additional help you need or you're looking for, rather than trying to go outside and learn a whole new platform. That's always been a difficulty, especially being the fact that for so long there's been one or two platforms that people have used consistently. The AutoCAD being pretty much a staple in the industry, and I don't see that going away anytime soon. Um, you want to have the ability to interact with that through different platforms that you may be using a SketchUp, or you may be using a different piece of software that you want to be able to transition back and forth from, but not lose any compatibility. And so I think it's, we are seeing that develop where um, you're starting to see like an industry standard, whether it's an IFC or something like that, where you can now at least, and again, we'll go back to the collaboration. That's a huge thing. This technology is great, but if it doesn't provide everybody to be able to collaborate the way that's the best for them, then I think that's where you might get into some roadblocks where you're going to have half the team working on one, so discipline, and half on another, and then not being able to provide that um, interoperability can lead to what you're talking about, where there's an HVAC run that I designed it in X, but I'm looking at it in Y, and I'm not able to put those two together so I can see that and detect it ahead of time. And then whether it's put an RFI out there or just talk to the design team or the HVAC contractor and say, yeah, this could potentially be a problem, and have that done early rather than later is, that's the holy grail. That's what everybody wants out there. That's what, if you spend any time working for um, a construction tech company, that's ultimately what they want, right? And it's a great goal to get to. But I think you're going to have to find companies that want to work together and not create their own, you know, kingdom, essentially, of you've got to stay with us or else. I think, giving people that opportunity to have other companies work with them to bring something in will definitely help in the long run.
It sounds like you're really describing the walled garden concept. I think everybody's seen that in some capacity with technology. Apple, for instance, very
Hmm.
compatible with other Apple products, not very compatible with other non-Apple products. Um,
Yep.
where do you see that shifting in terms of technology? Do you feel like a lot of the technologies are still those walled gardens, or do you see more opening up and greater
Yeah,
compatibility?
I think over time, greater compatibility, because in the initial run of most of these technologies, you find that you're developing these next steps, right? So if you're going to go from just doing a 3D model and then adding data to it, and then taking that data and putting it out to a total station, so you're taking it from the virtual to reality, you're going to want to work with your own, because it's just easier to develop, right? And you're going to be able to get it to market faster potentially, but also you don't have to worry about trying to collaborate with somebody outside of your company. As more and more companies start doing this and more new technologies pop up and there's more competition in the marketplace, I think you'll see where these companies will start, developing the ability to work with different manufacturers, right? Where you're gonna, because that is the ultimate goal, right? To have something that is digital, to then be able to use it in the field, because otherwise it's just not, there's not the bang for your buck if it's going to be something that's just going to be on somebody's computer screen, and then when it gets into the real world, it never quite works out as it does on paper in the real world. But you want to be able to bridge that gap so that you can then pivot, take that data that is in the real world and bring it back into your virtual models. So having that two-way interoperability, but also the two-way data exchange, is ultimately where everybody in construction is hoping it goes. We're in the very beginning stages of it, but that's ultimately where everybody wants to be heading, and it's going to be difficult to have one, two, or three companies have that walled garden, because I think that's just going to make things a little bit slower, right? And harder to adopt. And then constantly wondering, am I with the right tech stack? Am I with the right company that's going to provide all of that? Or I can't, my budget can't afford all that, but I can afford this from this manufacturer and this from this manufacturer. And if they can't talk together, are you really gaining much? So it's those
Mhm.
types of hurdles that, as you get to them, I think are going to be important decisions um, moving forward. And if they really want to get this to that end goal, there's going to have to be some give and take between some of the manufacturers and providers.
Yeah, it seems like there's the concept of the walled garden as it relates to the technology compatibility, but also in terms of the source of truth and whether that's held by one company or shared throughout all parties involved in the project. So everybody's collaborating using the same source of truth.
Yeah, it's like anything else in all tech across the board. You're only as good as what you're going to put into it. And if the industry is going to make it difficult to put the information in and then share it, it's always going to be a lagging tool.
It makes sense. And I guess looking at this from a tech provider standpoint, in terms of what kBridge offers, our goal is to align with partners and have pre-built standard integrations like we do to AutoCAD or Revit, for example, in the AEC world, but also having that more agnostic industry standard output like an IFC file that can be absorbed, imported into other tech and utilized there. It's interesting that you both refer to it as the holy grail. My experience is that's pretty tough to achieve, to have that single source of truth. It's not only just tech interacting with one another, but then it becomes cultural change within an organization to really subscribe to that philosophy of doing that, and then be disciplined enough to go through and ensure that your procedures that you're following and your methods of operation are consistent and allow for that. So not impossible, just effort, and none of that happens overnight. And it all costs money and takes time, and all those things likely everyone knows. But yeah, it's achievable for sure.
Yep. That's what we hope.
Yeah, right. Good stuff. Well, I guess would it make sense at this point maybe that I show off a little bit of kBridge and what we do specific to the precast structure industry?
Please do.
Yep.
All right. Let's see if I can get there. So the first thing I'll do here is say that I want to create a new configuration. Maybe we'll call this just with Holland and Matt. And I can add a number of different other elements here. But then I'm going to say that I want to go ahead and run what kBridge calls an application, which is a configurator by anybody else's terms. And so we're going to use this example to showcase one way technology can positively impact the building and utilities industry, really, and specifically precast concrete structure design. And I mentioned the MEP, mechanical, electrical, plumbing application that we have as one example of vertical application. Precast is another. And really the benefit for our customers in these selective industries is that they have a more rapid implementation of kBridge, and therefore they achieve a faster time to value in their kBridge investment. So really there are three ways that you can approach with kBridge. One is using one of these existing technologies as it is and getting benefits thereof. Another is using this as the foundation upon which you would build or create supplemental elements. And the third is to really use kBridge from scratch. And that's where Holland and his team at Mountain Point come in because they're able to provide not only the manufacturing industry experience, but also the resources that can support a kBridge implementation. So all that said, you have what is very much a prismatic looking block here on the screen. It is a top and a bottom portion here that is a concrete vault. You'll notice that it is a 3D element. You can look inside it here by evidence of the holes. And so let's kind of dive into the three different areas that we talked about here. As we make changes, the vault itself will update and so forth. On the left-hand side, we see a number of different elements. Maybe I'll start at the very bottom here, the settings pieces. So our customers who have administrative rights to this, the user I'm in here as does not, can set all kinds of things that are specific to the configurator, like what rebar types are used or set as defaults, what joint types for the top and bottom pieces or any risers between those, and so forth. But let's go to the vault area here. And again, out of the gate, we're able to resize the actual vault itself. And as I make these changes, you'll notice that the vault will update accordingly and change in size and so forth. So some of these elements are more obvious in different views, and you certainly can adjust how you are viewing them to ensure what you're doing is in fact what you intended to do, and see that digital twin, that digital design that's going on. Well, first let's focus to the industry intelligence and standards that we've baked in here. The first is just kind of going down a list here of what's displayed within the inputs, is the use of a top slab here. So perhaps you don't need a top riser piece of the vault itself, but rather you need just a cap for it. And you can see that adjusts accordingly. And not only does that adjust accordingly, but the overall height of 76 inches now is reflected here. Whereas we go back to having that top piece rather than just the slab, that the height adjusts back to what it was. The next is really change of thicknesses of things. So let's look at this straight on with hidden lines here. So the idea here is that we're now looking at the kind of the A wall of the vault, but the front of the vault in an elevation perhaps. And you'll notice that the hidden lines depict the different wall thicknesses. So if we were to actually change the base surface thickness from 8 to 12 inches, it's not a radical change, but you'll see now that the base where my cursor is here has actually increased in thickness. So there's a number of things also that happened, not as just specific that, oh, now it handles for whatever purpose, a bigger piece of equipment or perhaps provides more stability within the excavated hole. But the calculations appropriate are going on as well. So the overall height changes, the weight that's being calculated that is actually depicted on the drawing is correct, and so on. The next thing that we have here, as I zoom in, is the joint type. So there are different joint types, and probably easiest shown if I increase the height of the joint itself. So you can see that we have this hidden line here, and if I invert that, you can see it actually flips to the bottom. So this is just merely, think of it as a tongue and groove. It's actually how these two pieces are going to fit together. So again, it's important that not only are these selections available to conform with a particular RFI or a regulation or a code to which I need to adhere, but also then I can visually understand what they are and ensure that it meets my design intent. Likewise, I can go to a V-groove, which is a little bit smaller here, but you can see that V-groove here within the top piece, so forth. So let's go back to that inverted piece here, and we have that, and that looks good and what we want. And let's, from here, actually go back to and look at the risers piece. And once we go over to risers, I'm going to bring this back into a 3D or a shaded model, so it's a little bit more easily seen. So commonplace that these things are going to be stacked to actually provide for vertical access to something, or maybe taller pieces of equipment, or that the surface where these are actually excavated and located are going to be below the ground level surface substantially, so that you need to have these elements. And just as before, I can change a riser default height, I can change these individual heights, and all this will update, and all the while the overall height is being updated, and so on. In this case, maybe I don't need both of these, so I'll get rid of one of them, and that looks just fine. The next industry-specific element here, which is not just from a design perspective, but from a calculations perspective, everything from cut lists and actually conforming to requirements and so forth, is around rebar. So this is not, when you first look at this visual, it looks perhaps a little confusing, but see if I can't orient you to things. First off, again, there are three pieces to the vault. Right now, we have the top highlighted, but if I want to focus to the riser, I can choose that, and you'll notice how the shading changes. And then finally, the bottom, I can focus to that, each of which has its own configurable elements there. So again, purpose-built intelligence and standards built into the application to help really with the precast world. And then there are quite a few elements that are around single and double mat. So the default is single mat, meaning there's only one set of rebar. If I say in the top section that I want double mat, I can go ahead and show that. Let's zoom in a bit here and see if I can reorient the model somewhat. And you'll notice that I now have two sets of rebar here, where there was before only a single set. So again, just for clarity, we'll take away the double set or the double mat, and now we can put it back, and you can see that there's two sets there. So really, it's just further reinforcement. Again, something we can do. Likewise, we can adjust the clearance. So maybe we want 3 inches clearance rather than 2 inches. And in doing so, then as I reorient this a bit, you'll see that we've actually adjusted the change there and shown that the rebar has separated itself, and then we can adjust further clearance if it makes sense. And all of these things are governed by rules. So depending upon what either the industry says or what you as a corporation need from a design aspect, there can be guidance along the way to ensure that I can't build something that's not permissible or not allowable. And then there are other elements that I won't go too deep into, just in the interest of time, that are around the size of the hoop versus vertical bar. Hoop would be, kind of the horizontal pieces of rebar versus the verticals are just verticals. So let's go now to the lifters. And in doing so, you'll notice that, again, some industry specific elements here. If I look at some of these lifters that might not be real visual obvious here, but if I then look at the front and switch to hidden lines, you'll notice that I can more easily see what these look like. And if I adjust some of the sizes, make a more dramatic change, you'll see what those elements are. Common ones used are these lifter loops. So we can take those in and go from there. So really, that's all those things that we've shown, and even some of the openings that we're going to get into in a minute are industry-specific elements. But let's now talk about design, engineering, automation, because that ends up being time savings, to Matt's point earlier about how much effort it goes into and making sure everybody's in sync. So let's start with the openings pieces here. So you notice, in addition to some of the shapes that we have, there are these terminators, which we'd run pipe or conduit through to the internal of the vault. Again, something very industry specific. And if we first say that, I mentioned rules before, so let's say I want to drag an opening to a particular position on one of these sides of the walls, I then get really a nested configurator here where I can further configure not only the size of this, so let's say that we really want it to be a 25-inch diameter opening here, but I can also relocate that. And so the calculations that are going on here are substantial. And it could be that I just drag it to a position. Maybe I reorient and say that I really want this to be 16 inches, so 1'4", so I get an exact position. And you'll notice, again, the inverted groove that shows up here, the thicker bottom surface that we have as well. But if I flip back now to the rebars, what you'll also see is the engineering calculation that's gone on, and perhaps it's most easily shown if I highlight the bottom here, or maybe not here, but either which way, the intention is that the rebar is auto-calculating and designing itself around the hole. So it's not intruding into the hole, and if I were to move the hole, it would adjust accordingly. So again, that becomes incredibly powerful from a design standpoint, and that's one example of the automation that can be done. So we'll drop another opening on an opposite side. And likewise, I can adjust this guy. Maybe it's 40 by 40. And perhaps we'll go ahead and relocate that to the top piece here. That looks about right. And then just for completeness, let's go back to the rebar view, and we'll shade that top portion here, and you'll notice that the bar itself does not encroach. Tough to see here, there's a lot of bar going on here, but the top does not encroach there. So the goal here is, as I mentioned, design standards and industry intelligence really that's built in, the engineering design automation that's been done here. And then finally, we're going to get into the drawings and really automating those drawings. So what is powerful, what's happened here is one of the biggest challenges, and I won't speak for Matt, but I know in prior conversations we've talked about how a lot of the effort and work that happens around the drawing piece of things, and that's just frustrating because you really want to spend your time designing, not detailing and drawing. So kBridge takes care of that for you in terms of automating those drawings. Now, many things have happened. I didn't jump back and forth with the drawings because I wanted to showcase those other elements, but this drawing is being generated in real time, and the drawing itself has updated itself logically, intelligently, meaning that when we did not have these penetrations or openings in the two walls here, there was only a single elevation because there was no need to show the other walls because they had no different detail. Now that we've added openings in different walls, we see those other walls. Certainly, they're all being dimensioned appropriately, and we can assert that and adjust dimensions if we need to do any cleanup and so on. But there's more to this drawing just in views and dimensions. One aspect is the notes, the design notes that are in, and those are going to have logic to them. So depending upon what I choose in terms of the wall thickness or the rebar, whatever, those can be updated accordingly. Likewise, there's also a title block here that has some additional information, one of which is the overall weight of each piece here. Matt mentioned something earlier that I was focused on design. He talked about putting an RFP out or doing cost estimations. What a concept. What an absolute truth is if we're trying to figure out the amount of material or the shipping or trucking cost that this is going to take. You need to have these pieces of information in order to provide that accordingly. And there are other elements in the drawings that you can take advantage of. Let's flip before we get into too many more details. Let's go to the top piece here. Again, all these drawings were generated dynamically. So now I'm seeing in the lower right-hand corner here, or lower left-hand corner here, rather, I'm seeing the actual inverted groove that I have for the joint type. In the upper right, I have details around it's a cut list for the rebar itself. So not only does it tell me what type of rebar it is, but the quantity, their lengths, and how it's going to be shaped or bent, formed. So again, all these things are automated, and that just makes a designer's life a heck of a lot easier and easier to adapt to change or to go through multiple iterations of design, depending upon what the client need is. And we have the same for both the riser as well as the bottom piece of the vault. So you'll also may notice subtle changes here that the scale of the sheets is automatic. So the scale is actually adjusting depending upon how saturated, let's say, the paper space is, how many views there are, and so forth. The user can certainly adjust those accordingly. If I actually want to make these views a little bit bigger, I can go to 3/8 instead of 1/4 in scale. And then finally, just to prove a point from the drawing being smart here and updating automatically, let's go back to the openings and let's add an opening to the D side, the delta side of this enclosure. And we're just going to make it a 3x3 because we're going to have a number of different pipes and so forth passing through here. And then we can certainly locate that where we want it here. So that looks good. Now we have that. Now let's go back and see how the drawing has updated. And there should be a few changes here. One is that the view has been added. So because we add that detail to the wall D, we now have that third elevation and it is dimensioned appropriately. So once we have the drawing package that we need to have and the design is complete, we can go through the export process. So we're not actually talking about exporting the model in an IFC type format, which we can certainly do. Now we're talking about really the drawings itself, and the PDF is the most common, but certainly should you need to do other work or incorporate it into a larger drawing package, you can export in DWG, pull that into AutoCAD, and then add other notes or like I said, add it to other sheets of a drawing package where that's appropriate. So that was a whole bunch of stuff, and I know Matt has seen some of this before, but reviewed some of that. Matt, what are you thinking? Could that have helped what you had done in the past? Or? or what you're seeing
Yeah,
now?
yeah, for sure. I think and I see this type of technology would have been great back when I was detailing, doing my own bill of materials and takeoffs and all that good stuff. So, that this type of ability to take some of those areas that are monotonous, you know, sort of things you have to do that you don't want to do almost, and be able to not only quicken, part of that being that your productivity is going to increase because you're not doing some of that legwork necessarily, but you are spending a little more time on your actual detailing and being able to spend that additional time because you're not going to be stuck on the back end doing a lot of these labeling or dimensioning or bill of materials. As long as you have done the model correctly, you can spend additional time on that, which is more important, right? Is being able to have all that done versus knowing you have a certain amount of time to get the drawing package done, and knowing that it might take you a longer amount of time to do some of these other things, modeling aside, your layout, your bill of materials, take off, all that stuff. It allows you to, maybe you'll get it done a little bit faster, but what it does is it increases your time that you can spend on your accuracy.
On the design part of things, right?
Yep.
Yeah.
And that's huge, right? Because every day, you know, there's projects I work on where they're just going a little too fast because they're under the gun, and it's small things you see. Might be a label here or a dimension there, where it doesn't come up until you really need it. Versus now, if I could give that designer or detailer that additional time in his 8 hours, it still might take him 8 hours to do it, or maybe it only takes him seven, but out of that seven, 5 to 6 of it is true detailing and making sure I'm doing this correctly versus uh, additional hours just going in and putting labels and dimensions in, and then doing your initial bomb and then having somebody check that. Being able to get those things automated in a way that allows you to free up your time on the more important tasks, I think is in general what everybody wants in every industry, but in construction I think very important, because we're talking about things that, mistake here, mistake there. Bill of material, you can either be light or you can be heavy. um, Same thing with the drawing packages where this dimension, I left it off, or I didn't, I knew I would get back to it, except now the guy's in the field and he's trying to figure out what is this dimension that I need to build to. So it's those types of little things that I think this type of technology, integrated with software packages that guys have used every day for a long amount of time, will, your adoption will be faster, but also I think your path to actually getting a return on that investment will be faster.
Makes a lot
And
of sense.
Matt, I'm recalling an observation of yours from a previous conversation where, correct me if I'm wrong, but you mentioned something along the lines of the creation of the model is typically the 20%, and the revisions related to the technical drawings are often the 80% to get alignment and ultimate approval.
Yeah, it can be, depending on the project, but yeah, the revisions too, it's a good point to hit on. Um, Typically, if I were to go back in and touch a drawing, it's up to me then to know, out of let's say I have 4 pages of layout, which of those 4 pages and which of those views on each page I have to then go back in and change a label, a dimension, uh, you know, any of those things, where when you have a parametric solution where it's tied to your model, that I know if I change that, my layout's instantaneously going to be updated. That's a huge time savings, right? So I could make, whatever is requested. They can go out in the field, they could look at it, or they may have a change down the road, and they come in and they say, yeah, I need all these vaults to be, you know, uh, 10 inches shorter. And that may seem like a small change, and sometimes it is small. Other times I'm going to change 10 inches wherever it is, and it may show up on 3 of my 4 views. Now, in the old days, I'd have to go in there and I have to go through all those views and manually make those changes. With this type of a solution, once it's changed in the model, then it works its way down automatically to then I'm just going in and checking all these layouts. That is a huge time savings. And also from a frustration level, that when you're on that detailing level, it can seem, there's a frustration there. Why are they changing this? Like you're not really aware of what's happening upstream, and you just think that sometimes it's just you know, this is such a pain. Why do I have to do it? Because of those downstream effects, right? You take that out of the equation, and I think that not only does it help your productivity, but morale wise, I think it helps as well. From having been in that position, that was always, revisions were always a thorn in your side, that was a necessary evil, because there are things that, to the outside world appear small, but when you put it in the hands of a detailer and realize all the effects that happen to not only the individual drawings, bill of materials, all that stuff. So those types of things to me, they stand out for me, where it would have saved me a lot of time back in the day.
Yeah, well said. So let's see. Maybe as we kind of head over toward wrapping things up, or as I've heard Mike Rose say, as we land the plane, Holland, maybe you can opine on what you see. So Matt says, "Hey, this stuff works." I say, "Hey, this stuff works." Um, what are you seeing with customers? Where do maybe they have hangups, or where do they have misconceptions around technology adoption implementation?
Yeah, we've definitely seen a shift in recent years, a shift away from large big bang implementations across entire product lines. Those projects can be quite expensive and take sometimes years to deliver. Instead, companies seem to be leaning towards more agile approaches. So sometimes starting with just a proof of concept or minimum viable product. So a way that we can show the value early and upgrade that iteratively. So this seems to be a much more common path for customers we've been working with recently.
Yeah, man, I applaud people, at least from my experience, that have these grandiose visions, and certainly don't want to lose sight of those visions. But whatever cliche you decide, crawl, walk, run, or do the MVP or the POC ahead of time, and then ultimately, or Matt, I know you've talked about people that many times haven't invested in training for maintaining the application, and they just kind of bought the application or subscribed to it or whatever you want to call it, and then
Yep.
things go off the rails because they're not well trained, or it's never adopted because they're not trained.
Yeah, I think excellent point, and I would tell anybody out there who's thinking of putting any types of these technologies into place, it's to speak with your team, get an idea of their skill level, and then invest in them in addition to investing in whatever software you're going to provide. It's not something to overlook. And although people may say they don't need training, there is a decent amount, let's say, of them that will over or underestimate what they need, and just be honest with them, and be honest in the fact that you're not just buying some software, but you're investing in them as well.
Yeah, that's a good description. Investing in them as well. Yeah, that's in Holland. I'm thinking you and your team see the same. It's again, you want to be a responsible service provider for your customers and your clients, and yet you don't want to always have to give them the bad news, or you feel like you're a negative Nancy, so to speak. It's one of those. Gosh darn it, why are you bringing such a rain cloud over here? It's not that. You're just being responsible to them, and you're telling them, hey, this stuff takes effort, and let's be smart about how we approach it and how we invest in it. Yeah,
Perfect. Well, I think this has been great. Really appreciate your time, Matt, joining us today, and your perspective on these industry challenges and hopeful solutions coming.
Yeah, no, thanks for having me. I think everything looks promising, and I'm looking forward to seeing what comes next.
terrific. Thank you, Matt. Thank you, Holland.
All right.